Right.
Why not go with the hollow core and with the 30 feet wide, it takes 40 feet wide and open one
Right.
basement,
And, you
no
know,
column, no post.
right. And we are seeing that for more of the upper end houses, kind of high end houses. You know, the architects do like using hollow core floors over the basement for that exact reason. You know, because then you have this open space underneath, you know. So if you want to put your basketball court underneath your garage, you can do that. But that's not how my house is, but some swimming pools, basketball courts, yeah, that kind of thing is what, you know. So there's a certain price point that you have to hit before I see that happening. You know, there are communities where we're seeing some precast housing, but it's difficult to hit the price point where it's effective. I don't know, are you guys seeing any of that?
I would agree. We don't. Our company really doesn't do as much residential type. We've done some condo buildings or things like that. But as Marty points out, one of the things that makes precast, it can be as unique as you'd like. Those forms, we can do multiple colors and finishes and clad it with brick and other things, which we can talk about more if there's some interest. But you do need to make the pieces relatively large and relatively repetitive because of the forming costs that are involved. And that's really one of the keys to keeping the product economical and making it work. And as Marty says, if you have a lot of forms to build and you can't get that repetition out of the project, it makes it a little bit tougher.
Any,
One time you mentioned twisting, making a lot of things with price of
no, you want to talk about the difference in a small piece versus large piece?
Yeah, and
Price?
yeah, thanks, Marty. In a lot of the buildings that we do, you know, we always, when we're working with architects and contractors and engineers and trying to come up with these designs for these buildings, and I'm speaking mostly about architectural per se, but we've always found that when I talk about larger pieces, that when you take that whole elevation of the building, and if the architect is looking for some assistance in piece sizes, if you will, or doing a takeoff in design, we try to keep those pieces relatively repetitive and relatively large, somewhere in the neighborhood of 100 square feet per piece or larger. And we found that actually the more you can pump that number up a little bit, the better your cost per square foot is from an erection standpoint. Because erectors typical charge by piece, I don't know, in Chicago right now, but $2,500, $2,500 is probably not unusual. So I mean, if you can knock your you know, double your piece size, if you will, you're going to cut down your erection cost per square foot in half.
Yeah,
So it's very significant. The crane doesn't care if it's picking up a 50 square foot piece or a 250 square foot piece. You still have to use the same piece of equipment to get that building erected. So why not have fewer pieces, fewer joints, and make the pieces relatively large where you can?
Yeah, I always think in terms of a column cover. So if you have a column cover and it's 1 foot by 12 feet or 20 feet, let's call it 1 foot by 10 foot, make the math easy, and then it's $2,000 to pick that up and put it on the building. Let's do the math. How much is that per square foot? It's $200 per square foot. So, you know, if you could do if the precaster can work with the designer, so maybe you punch out the window and you have 2 column covers and the spandrels up above and below the windows, all as one piece, then you're picking up fewer pieces and the cost per square foot really starts to go down. So that's one of the areas where it really starts to make a difference in terms of the cost of the precast construction. Any other questions about the products? Or I thought I would also kind of take you through the typical places where you're going to see our products used. One are athletic facilities. I didn't really go through the riser beams and raker beams that you'll see, but we see a lot of athletic facilities, whether it be, I drove past Busch Stadium. This is a picture of Soldier Field in Chicago, Comiskey Park. So whether it be a large professional stadium or that's Milwaukee College of Engineering, their recreational facility. So we're seeing a lot of recreational facilities using precast concrete.
The athletic structures can use both structural and architectural as well. The Indianapolis Colts, keep grabbing, don't mean to steal your thunder, Marty. The Indianapolis Colts, just to give you an example, just built a new stadium, the Lucas Oil Stadium, if any of you have heard about it or familiar, maybe seen it on TV. But the exterior of that building, it looks like a masonry structure or a masonry exterior, but that's actually insulated brick-clad precast panel system on that building. The architects wanted something that would erect very quickly, would have some energy-conserving properties, so they wanted an insulation board to be sandwiched in between the concrete layers for efficiency. And again, it would erect very quickly and be very durable. So.
Athletic or educational facilities, a lot of K through 12 schools are starting to use precast, especially if they have to meet tight construction deadlines, and they need to build through the winter. I mentioned earlier, there's not a lot of winterization that you have to do with precast. So that can be quite helpful. You know, you don't have to get those big sheets of plastic up over the whole thing. You can pretty much put precast up all winter long. The things that are going to stop you if it's too icy for the crane to operate, really high winds and lightning. But other than that, you can pretty much put precast up 12 months a year. And so that's one of the reasons that educational facilities really like it. They also like the, Mark was talking about the insulation. You can put insulation in the wall panels, and so you really have almost like a thermal cooler heating and cooling the whole structure. And a lot of school facilities really like that idea because they can then downsize their HVAC system, and it's going to be more cost efficient to operate that school in the long term. So a lot of them like that as well. We also see a lot of healthcare facilities, hospitals, nursing homes, anything where fire is an issue or where you want a very clean room. We do see a lot of that. I know, especially with architectural precast, we're seeing a lot of hospital construction. I looked at one of his projects today in an architecture firm I was in. Industrial facilities, anybody who travels up to Chicago, you probably see warehouse after warehouse after warehouse. And in the Chicago area, we've really perfected the art of the precast concrete warehouse. But you can have very clean facilities. If you need to have daylighting in it, you can have daylighting. These are usually driven more by price than by design. The kinds of stuff that Mark's company works on really is driven more by the design. But these are usually pretty simple boxes that the cost is really going to be the key factor. A lot of municipal buildings. I laugh, people keep asking me, like, what are your members building these days? And everybody's building water treatment facilities. So that's the big hot market right now, other than healthcare. But, you know, also courthouses, libraries, any kind of municipal building, we're seeing a lot of those as well. Offices. A lot of architectural precast goes on offices, but again, you can use that entire precast structure and frame. This is actually the FBI building in Chicago. Do you know much about that building? That's one of his projects, but it's in Chicago. So, that kind of brings to mind one of the other things that our institute has been doing a lot of research on is blast-resistant design.